Good afternoon, everyone. This is the pre-launch news conference for NPP to be launched aboard a Delta II rocket from NASA's Space Launch Complex 2 on Friday morning. Our first briefing will discuss the countdown and the flight of the Delta II, and then we will have a second briefing that will discuss the objectives of the NPP spacecraft. That will immediately be followed by a briefing on our CubeSat satellites, also attached to the Delta II. Participating in our briefing today will be first Andrew Carson, the NPP Program Executive from NASA headquarters in Washington; Tim Dunn, the NASA Launch Director from the Kennedy Space Center; Vernon Thorpe, the Program Manager for NASA Missions for United Launch Alliance in Denver; Ken Schweer, the NPP Project Manager from the Goddard Space Flight Center in Greenbelt, Maryland; and Lieutenant Lisa Cochran, the Launch Weather Officer from the 30th Operations Support Squadron at Vandenberg. And we'll begin first with Andrew Carson, our NPP Program Executive. Andrew?
Thank you, George. We are very excited about the upcoming launch of NPP. NPP is a bridge to the next generation of Earth-observing satellites and will provide measurements that are critical to NASA's Earth science research. NPP will help us understand what tomorrow will bring, whether by tomorrow we mean tomorrow's forecast or whether we mean years or decades down the road. Could I have the first video, please? NASA is currently operating 14 Earth-observing missions, including a series of satellites known as the Earth Observing System, or EOS. These satellites, Terra, Aqua, and Aura, provide key measurements about our land, oceans, and atmosphere. NPP will continue these measurements, which are critical for understanding the health of our planet now, as well as how things might change in the future. NASA is taking what we learned with the EOS program and NPP and helping NOAA create the next generation of satellites to extend these measurements into the future. And that program is called the Joint Polar Satellite System, or JPSS. Could I have the next video, please? NPP will lay the groundwork for the JPSS system by proving out the capabilities and technologies of both the instruments and the ground system. The NPP data will also be incorporated into operational weather forecast models, providing higher resolution data and improving our weather forecast capability. So NPP is a critical first step in creating a climate-capable operational system. This mission was developed in collaboration with our partners at NOAA and the Department of Defense, as well as our industry partners in Ball, Northrop Grumman, Raytheon, and ITT. So as we finish up the last of the launch preparations, we look forward to the launch of NPP. We know it'll become a significant part of our nation's climate and weather monitoring system. George?
Thank you, Andrew. And now to Tim Dunn, the NASA Launch Director for a flight on Friday morning. Tim is from the Kennedy Space Center. Tim.
Thank you, George. I'm proud to be here today representing the men and women of NASA's Launch Services Program. The NPOS Preparatory Project, or NPP, is my second mission as NASA Launch Manager, and I'm thrilled to continue my Launch Director duties with a Delta II launch spacecraft that will serve as the first step in building the next generation of Earth-observing satellites. In addition to NPP, NASA is pleased to launch 6 small satellites called CubeSats on this mission. NPP will launch on a Delta II 7920 vehicle from Space Launch Complex 2, affectionately called SLC-2. NPP will be the 357th Delta rocket to launch since May of 1960. SLC-2 is proud to have hosted 80 of those Delta launches to date. Over the past week, the Delta II team has been busy with launch preparations. Last Friday, the combined NASA and ULA launch team held the Flight Readiness Review, where we assessed the preparations of the Delta II launch vehicle, range and facility assets, and the readiness of the NPP spacecraft. On Monday, we performed a successful mission dress rehearsal and loaded the hypergolic propellants onto the second stage on Monday and Tuesday. Now I'd like to show a video of the ULA crew building up the Delta II launch vehicle at SLC-2. Please roll the tape. Here you see the arrival of the first stage being offloaded here at Vandenberg Air Force Base back in June of this year. The first stage is manufactured by ULA in Decatur, Alabama, and then shipped cross-country. Here's the second stage arriving about a month later in July, again being offloaded and set on its over-the-road trailer where it will be transported to Slick 2. This is a video showing fairing erection into the mobile service tower at the launch pad at Slick 2. This occurred on July 19th. You can see the fairing going up the side of the tower and will be positioned inside the clean room, awaiting the launch vehicle erection and then arrival of the satellite. On the next day, we brought the first stage out to Slick 2 and did erection onto the launch mount. You see connection here to the overhead bridge crane, erecting the first stage. There's the RS-27 first stage engine, a nice shot of that. You'll see the first stage being brought into the mobile service tower and then used as a moving crane. The MST will then be rolled back over the launch mount. And you can see the first stage being lowered onto the launch mount here. There are 6 launch legs that we precisely set the first stage down on. Beginning about a week later, we brought out the solid rocket motors. NPP is the 7900 configuration of Delta II, so there'll be 9 of the GEM 40s, graphite epoxy motor, 40-inch diameter. And you can see using the same overhead crane from the MST, bringing that into the MST and attaching to the first stage. Here's second stage hoist and mate, and that occurred on August 2nd of this year. The second stage, again manufactured in Decatur, Alabama. You see the Aerojet HA-10 engine on the bottom half of the second stage, and here is the stage being lowered and mated to the first stage. And here is the spacecraft coming out on the morning of October 13th, a little under 2 weeks ago. The spacecraft, the NPP, was brought out in its transportation can. We waited an extra day due to high winds on the 12th of this month, but on the 13th it was a beautiful day and light winds. Brought the transportation can up into the clean room and gently lowered it down and mated it here to the top of the second stage. And then this is fairing installation. Beautiful shot of the satellite there. And the fairing halves are brought in and around the spacecraft. This occurred last Thursday. Nice shot of one of the sectors in place for the fairing and the second bisector coming in for mate. And we had an incredibly smooth payload fairing mate last week. This morning, we held a successful launch readiness review and received approval from senior NASA and ULA management, as well as spacecraft and range agencies, to proceed with initiating our launch countdown beginning tomorrow evening. At Slick 2 today, we performed range safety and beacon checks, along with first and second stage engine slewing checkout and the final azimuth update, and loading that update into the flight computer. On Thursday afternoon, we will begin final launch pad preparations at approximately 3 p.m. Pacific time, when we will load the RP-1 fuel onto the first stage, and we will then move the mobile service tower into the launch position. The launch team will arrive on console approximately 10 p.m. tomorrow evening, and we will then perform final launch preparations of vehicle power on and pressurization right before midnight, followed by first stage liquid oxygen loading at 1 a.m. Final engine slews will be performed approximately 2 a.m. Friday morning, and then we will be ready for our T0 at 02:48:01 a.m. Pacific time. We have a 9-minute and 10-second window and are looking forward to a successful launch of the NPP spacecraft. Back
Thank
to you,
Tim.
George.
We'll go now to Vernon Thorpe, the program manager for NASA missions from United Launch Alliance. Vern?
Hey, thank you, George. On behalf of Michael Gass, our president and CEO, and the 3,700 men and women of ULA, I'd like to say that we're proud to support NASA and the launch of the NPP mission. This will be the 50th Delta II that we've flown for NASA. This will also be ULA's 10th launch this year, and it will be ULA's 55th launch overall. In addition, this is the fourth of 5 missions that we are launching for NASA this year in just under a 6-month period. We've worked closely with the NPP spacecraft team and with our partners in KSC's Launch Services Program for several years preparing for this launch. The integration work is complete. The launch processing is in its final stages, and we are ready to launch the NPP spacecraft into a polar Earth orbit. This launch will be a critical step in developing our country's next-generation Earth-observing satellite system. It's also worth noting, as Tim pointed out, that we have a few CubeSats on board as well. We actually have 3 what we call P-pod dispensers on the front end of the upper stage. And distributed among those 3 P-pod dispensers, we have 6 CubeSats that we'll be deploying. We'll be doing that after completion of the primary mission, about 40 minutes later. These CubeSats were provided by the University of Michigan, the University of Montana, Auburn University, and Utah State. The NPP mission will be launched aboard a Delta II 7920-10 vehicle featuring a ULA first stage powered by a Pratt & Whitney Rocketdyne RS-27A main engine and 9 Alliant Tech System solid rocket motors. An Aerojet AJ-10 engine will power the second stage, and the payload will be protected by a 10-foot diameter composite fairing during the first few minutes of flight. Tim showed us a video of the processing and activities that led us up to where we are today. I'd like to show you a video of what we plan to see on launch morning. If we could go ahead and roll that. Okay, when this vehicle lifts off, it will weigh about 500,000 pounds. We'll lift off with a thrust of 650,000 pounds. And the first major event you see will be the burnout and jettison of the 6 ground-lit SRBs. Those will burn out about 65 seconds into flight. We'll jettison them about 86 seconds into flight. Before we jettison those, we'll light the 3 air-lit SRBs. Those, again, will burn for 65 seconds. We'll jettison them about 130 seconds into flight. The main stage, the first stage, will continue to burn until we deplete all the propellants. That will happen about 4 minutes and 20 seconds into flight. At that point, we'll shut down the engines, we'll separate from the upper stage, and we'll begin the first of several upper stage engine burns. The first burn that we see on Friday morning will last about almost 6 minutes, 5 minutes, 47 seconds, and that will take us into an intermediate orbit. We'll have a 42-minute coast in between, and then we'll do the second engine burn that will put NPP into its desired orbit for separation. You saw the payload fairing jettison there a few seconds ago. That jettison will happen shortly after the first upper stage engine burn begins. So the second burn will complete about 52.5 minutes into flight. We'll take a few minutes to reorient the upper stage, and then we'll separate the NPP spacecraft. Separation is nominally scheduled to happen about 58 minutes and 45 seconds into flight, so slightly less than an hour after liftoff. Now, after we complete what we refer to as our primary mission, we then do a second, or I should say a third engine burn, and after that third burn, that's when we'll jettison the P-pods, the 6 CubeSats that we're carrying in the P-pod deployers. And that will occur about an hour and 40 minutes into flight. And then finally, we'll do a depletion burn of the upper stage. We're proud to serve a critical role in delivering one-of-a-kind NASA payloads to orbit in support of the global science community. And we're focused, ULA is focused on perfect product delivery. That means for every mission, we focus on one launch at a time, and we work on continuous improvement in meeting the needs of all of our customers, NASA and our other customers. NPP represents the culmination of years of hard work by the NASA and ULA launch teams, and we anticipate that our reliable Delta II will safely deliver the spacecraft into its desired orbit, and we look forward to the important Earth observation data that NPP will provide. So once again, I'd like to thank all of our mission partners who have worked with us tirelessly to make this launch a success. And now I'll turn it back to you, George.
All right, thank you, Vern. And now to Ken Schweer, the NPP project manager from NASA's Goddard Space Flight Center. Ken.
Thank you, George. Just a few miles from here sits the NPP satellite on top of the Delta II launch vehicle as we complete all our preparations for our launch on Friday, October 28th. Can I have the first video, please? Once the NPP satellite separates from the Delta II launch vehicle, the satellite starts an automated sequence where the control system maneuvers the satellite for solar array deployment. This makes sure we get the proper power into the system so we can have the health and safety of the satellite where we need it. After deployment, the communication systems on the satellite is configured for ground contact. This is when my mission operations team has the first opportunity to verify and ensure the safety and health of the satellite. This all happens in about 30 minutes after separation. The NPP satellite will orbit 512 miles above our homes and will be controlled from NOAA's Satellite Operations Facility in Suitland, Maryland. The NPP satellite will send down about 4 terabytes of data a day to Svalbard, Norway, which is an antenna site inside the Arctic Circle. 4 terabytes of data is approximately 800 DVDs of storage. This is what makes the aerospace industry so exciting. One day, a person has a concept to meet our nation's needs. Next, that concept is put to paper, where many dedicated people work as a team throughout the development, until one day, a satellite like NPP is ready for launch. The challenges, triumphs, and relationships during NPP will last a lifetime and support and help future endeavors. During my NPP team's journey, we successfully maintained schedule the past 2 years while completing a satellite comprehensive environmental program and ensuring the readiness of the ground system and the mission operations team. The NPP satellite was built by Ball Aerospace in Boulder, Colorado, where all 5 instruments were delivered and integrated to the spacecraft. After integration, the NPP satellite is about 13.5 feet long and weighs about 4,500 pounds. It's a pretty nice sized SUV. Can I have the next video, please? The NPP satellite was shipped from Boulder, Colorado and arrived at Vandenberg Air Force Base on August 30th via an environmentally controlled shipping container. Here you can see the team carefully removing NPP from the shipping container and installing it on our mechanical support structure. The mechanical support structure is key because it can elevate and rotate the spacecraft to any position so our engineers can prepare NPP for launch. After we complete all the preparations, a protective canister is installed over NPP. Here you can see them building it up and lowering the top half. Once they're complete with those operations, we carefully and slowly, of course, in the wee hours of the morning when it was dark, take this 2-mile trip out to the Delta II launch pad. This is where Tim has showed you that the canister is lifted and we're finally mated to the Delta II, which we've been working on for years to get to. This week, the NPP and Delta teams completed all readiness reviews and the mission dress rehearsal, which prepares the launch team with simulated anomalies. NPP is ready for launch. The NASA Goddard Space Flight Center role in NPP is to manage the entire mission for NASA's Earth Science Division. This included acquiring the spacecraft, 2 of the 5 instruments, working with the Kennedy Space Center for the Delta II launch vehicle, and overall mission systems engineering and early orbit operations. Over the past 5 decades, the NASA Goddard Space Flight Center has managed and launched over 260 successful missions into space. NPP has touched so many lives already, and my team is so excited for NPP to touch the rest of the world with climate studies, enhanced weather forecasting, and monitoring of critical events. NPP's bumper sticker could read, NPP, our planet's lifeguard. Thank you. Back to you, George.
Thanks, Ken. Now the weather forecast for Friday morning. Lieutenant Lisa Cochran, the launch weather officer from the 30th Operations Support Squadron. Lisa.
Thank you, George. The month of October is part of a transitional weather season for the Central Coast of California. It's marked by the disruption of the marine layer and the associated fog we see with that by low pressure systems moving down the coast. If you'll turn to the current satellite loop, one of those low pressure systems made its way in from the northwest just a few days ago, and we received cold frontal passage this morning. You can see as it continues to push off to the east, the clouds associated with it. As it does continue to move off to the east, high pressure is going to start to build back in behind that, which is going to create an offshore flow for us here at Vandenberg. With this wind pattern, it'll keep that marine layer well off the coast, and it'll give us unrestricted visibility and favorable sky conditions for launch day. So the forecast for the launch window for October 28th, you can expect upper level clouds, view coverage from 25,000 feet to 27,000 feet with unrestricted visibility and no weather. Our winds will be out of the east around 8 to 12 knots, and temperatures will range in the upper 40s to low 50s. And finally, for the 24-hour scrub forecast on the 29th, expect very similar conditions as the previous day, just increasing upper level clouds around 5/8 coverage from 24,000 to 28,000 feet. Still unrestricted visibility and no significant weather, and our winds will still be out of the east around 8 to 12 knots, and temperatures still the same as well. This gives us an overall probability of 0% for both T0 and for the scrub day as well. Our launch weather team is going to continue to monitor the weather up through the launch window, and it will make any updates as needed. But it's going to look like it's looking to be a very favorable weather conditions for launch day. Back to you, George.
Thank you. And we're ready now to take questions. Please give your name and affiliation when the microphone comes to you. So we can start here in the front. Any questions for our media here in the room? All right, no questions for our media here. And any questions from the media at the other NASA centers? All right, no questions at the other centers. Well, we do have a question from Justin Ray.
Justin Ray with spaceflightnow.com. I guess for Ken, I was wondering if you could compare NPP to the previous polar orbiter, weather satellites, and so forth, how big of a leap NPP represents from previous missions of this sort.
I can address that somewhat. I do encourage you to stick around for the next briefing where my project scientist, Jim Gleason, could give a more thorough answer. But one of the things with our partnership with NOAA that we've had in over excess of 40 years, on our research satellites like the Earth observing satellites, where we do the research, that also gives us the opportunity to prove out those instruments and those capabilities. So on the next generation weather satellites, we can start to factor in that technology and that resolution into the weather community. One aspect of NPP is sending down about twice as much data as each of our Earth observing satellites.
All right, we have one question that's come in online, and Steve Cole from NASA headquarters will read that to us.
Thank you, George. This is from Steve Rousseau at Popular Mechanics. It's for Ken. How long will NPP be operational?
The NPP instruments have a design life for 7 years. This mission, NPP, was always envisioned to be a risk reduction mission for the overall operational system. So the NPP spacecraft is a 5-year design spacecraft bus. Of course, like all our satellites, we want them to live as long as we can. But during the development of 3 of the instruments, VIRS, CRIS, and OMPS, that was delivered by our partners, there were significant development issues that arose throughout the years, which leaves residual risk in those instruments. The teams did everything they could to make sure that it was appropriate instrumentation for the NPP risk reduction mission. The follow-on program, JPSS, has had an undertaking to go through all the requirements, all the lessons learned from NPP, whether it's from a hardware, design, manufacturing sense, and incorporate as much as they can to where we have a better feeling of those instruments from a longevity sense. Also, the lessons learned from NPP, the NOAA and the other scientific and operational users, this gives them a time to update algorithm and data products, So when the operational system comes on, there's a much better sequence there. See, everything about NPP is new. The instruments are new, the spacecraft's new, the ground system's new. So this gives us an opportunity, which I like to call clean out the pipes for JPSS. Make sure everything is working for when the operational system comes online.
Additional questions. How is NPP going to help predict hurricanes and other major weather patterns, and how important is this data to that effort?
Well, I definitely encourage the person who asked that question to listen to the next briefing.
Okay, great. One last question. This was directed to Andy. When will JPSS, the mission that you mentioned, take over for NPP, and why was it delayed?
Well, the JPSS mission, we can get you in touch with the JPSS program later on, but I can tell you right now the JPSS mission, JPSS-1, is planned for launch in late 2016. And given the 5-year operational life that Ken just spoke to, that would be picking up right after the end of NPP's operational life. So.
All right. Any other questions from media here in the room? All right. In that event, we will pause just long enough to change our players here on the dais and go into the NPP mission science briefing. Thank you.